Welcome. This is Kimberly Gerardo and Rufa May Godinez as your presenter for Chapter 9, which is entitled Project Scheduling, Program Evaluation, and Review Technique or PERT, and the Critical Path Method or CPM. So before we get started, let us first know what are our objectives in this lesson. So first is to understand what is PERT or CPM. Second, to comprehend project scheduling with known activity time and with uncertain activity time. To learn the concept and determine critical path. To know the contributions of PERT and CPM. To be knowledgeable to critical path procedure. To determine the project's critical path. And to find out how CPM is used as a procedure to develop the activity schedule for the project. So next, let us know the overview of this topic. So first is the project scheduling with known activity time. So under this topic is the concept of a critical path, determining the critical path contributions of PERT and CPM, and the summary of PERT and CPM critical path procedure. Next is project scheduling with uncertain activity time. So under this one is the Doherty Portavac project. Second is uncertain activity times. Third one is the critical path variety in project completion time. So next is the considering time cost trade-offs. So under this one is crashing activity times in linear programming model for crashing. So now let us have the introduction to project scheduling PERT or CPM. So, in many situations, managers are responsible for planning, scheduling, and controlling projects that consist of numerous separate jobs or tasks performed by a variety of departments and individuals. Often, these projects are so large or complex that the manager cannot possibly remember all the information pertaining to the plan, schedule, and progress of the project. In these situations, the program evaluation review technique or PERT and the critical path method have proven to be extremely valuable. PERT and CPM can be used to plan, schedule, and control a wide variety of projects. So these are the examples for those projects. So first is the research and development of new products and processes. Second is the construction of plants, buildings, and highways. Third is the maintenance of large and complex equipment. Fourth is design and installation of new systems. So in these projects, project manager must schedule and coordinate the various job or activities so that the entire project is completed on time. A complicating factor in carrying out this task is the interdependence of the activities. For example, some activities depends on the completion of other activities before they can be started. Because projects may have as many as several thousand activities, project managers look for procedures that will help them answer questions such as the following. Number 1, what is the total time to complete the project? Number 2, what are the scheduled start and finish dates for each specific project or activity? Number 3, which activities are critical and must be completed exactly as scheduled to keep the project on schedule? Number 4, how long can non critical activities be delayed before they can cause an increase in the total project completion time? So in PERT and CPM, those questions can be answered. Although PERT and CPM have the same general purpose and utilize much of the same terminology, the techniques were developed independently. PERT was developed in the late 1950s specifically for the Polaris missile project. Many activities associated with this project had never been attempted previously, so PERT was developed to handle uncertain activity times. In CPM was developed primarily for industrial projects for which activity times were known. CPM offered the option of reducing activity times by adding more workers or resources, usually at an increased cost. Thus, a distinguishing feature of CPM was that it identified trade offs between time and cost for various project activities. So, in PERT is from Navy and CPM is DuPont and Remington Rand. So, it differs because they were developed by different people working on different projects. Today, the best aspects of each have been combined to provide a valuable project scheduling technique. So, project scheduling with known activity times. So this is the problem. So the owner of the Western Hills Shopping Center is planning to modernize and expand the current 32 business shopping center complex. The project is expected to provide room for 8 to 10 new businesses. Financing has been arranged through a private investor. All that remains is for the owner of the shopping center to plan, schedule, and complete the expansion project. So let us show how PERT and CPM can help. So the first step in the PERT or CPM scheduling process is to develop a list of activities that make up the project. So as you can see in table 9.1, it shows the list of activities for the Western Hills Shopping Center expansion. So these are the activities. So activity A, B, C, D, E, F, G, H, I. So its activity description is for A, prepare architectural drawings, B, identify potential new tenants, C, develop prospectus for tenants, D, select contractor, E, prepare building permits, and F, obtain approval for building permits, G, perform construction, H, finalize contracts with tenants, and I is tenants move in. So here in immediate predecessor, information determines whether activities can be completed in parallel or work on simultaneously or in series, one completed before another begins. So generally, the more serious relationship present in a project, the more time will be required to complete the project. So here in immediate predecessor, so for activity A and B, so it can start immediately. So wala siya giagad nga other activity. So um in activity C, D and E kay kanang dapat mahuman pa ang A before sila maka-start. So before maka-start ang C, D and E, dapat ang A kay mahuman sa and sa E rather F is to obtain approval for building permits dapat dili maka-proceed ang F if wala pa pud nahuman ang E. Then in G, perform construction if wala pa nahuman ang D and F, therefore dili ka proceed ang G as well as sa H which is the B and C. So if wala pa nahuman ang B and C, dili maka-proceed ang H. And in I, if um G and H is not yet completed, so dili maka-proceed ang activity I. So that is the immediate predecessor. So in activity A, it is to be said that um 5 weeks ang span sa time sa activity. So in B, 6, C, 4, D, 3, E, 1, F, 4, G, 14, H, 12, and I, 2. So a total of 52, 51 rather. So next is using the immediate predecessor information in Table 9.1, we can construct a graphical representation of the project or the project network. So what is a project network? A project network is extremely helpful in visualizing the interrelationship among the activities. No rules guide the conversion of a list of activities and immediate predecessor information into a project network. The process of constructing a project network generally improves with practice and experience. So, this is an example of project network for the Western Hills Shopping Center. So, 'di ba sa table, A and B can start immediately. So, sila ang nag-una, 'di ba? So, you observe. And as you observe, A, let's change this. Mm, so as you can see, A A here. Oh, why is it missing? Wait a minute. So A here and B here, since they can immediately start, so sila ang una sa starting line. Then, 'di ba, it is to be said that um dili maka-proceed ang E, D, and C if project activity A is not yet finished. So therefore, mo proceed ang E, D, and C after mahuman sa A. So mo na siyang ang E, D, and C is after the A activity. So an E here is preceded by F, G, I, then finish. And in D here, preceded by G, I, then finish. And C here is H, I, then finish. And B here is the H and I, then finish. So um you can see here that ang kaning intermediate predecessor is really important in making project network, since dili ka maka-identify unsa ang dili ka maka make aning project network without the immediate predecessor, since ang immediate predecessor siya man ang mag-identify if unsa nga mga activities ang mo proceed sa kanang certain nga activities. So next is the the second figure, or figure 9.2 of the Western Hills Shopping Center project network with activity time. So, 'di ba, ganiha is just the activity description ang nakabutang. So, here is just the activity. So, activity A to I, but then nadugang nawala ang activity description, but ang nadugang is the activity time. So in A, we have 5 weeks, in E, 1, and B, 6, and D, 3, C, 4, F, 4, G, 14, H, 12, and I, 2 weeks. So, mana siya ang sa, um, what you call this one? Sa project network with certain time. So, here, the box here, kani mga box din kani, ay, sorry, kani mga box din it is called the nodes. Mga nodes na siya. Then, ang kaning mga arrows here, mga lines and arcs, it is called, the lines with the arrows, mo na siya. It is called the arc. So, remember, ang kaning mga rectangles is called the nodes, Nodes, and while the arrows here and the lines are called arcs. So, to determine the project completion time, we have to analyze the network and identify what is called the critical path for the network. So path is the series of nodes connecting using arcs from start to finish. So path here, for example, is the BHI. So path B, H, and I. Since path is the kuan man is the series of nodes connecting using arcs from start to finish. So kaning mga nodes connected by arcs rather. So muna siya ang mga paths. So for example, path A, E, F, G, I, finish. Muna siya ang path. So another path is A, D, G, I. And another path is A, C, H, I. So muna siya ang mga path. So here, so we already know what is a path. Let us know what is a critical path. So the critical path is a path wherein delayed of a certain activity will cause delays in the following activities. The longest path requires the longest time, thus the path is our critical path. So activities on the critical path is called critical activities. So for example, critical um the longest critical the longest path here is A, E, F, G, and I. So this path is our critical path and it will be proven in the next slides nganong critical path ang kaning A, E, F, G, and I. Because if A will be delayed, if ang A is ma-delayed, then ang E, F, G, and I will also be delayed. Whereas in path A, D, G, if ma-delayed ang D, if ma-delayed ang D, ang G won't be delayed. So mo na siya ang kanang principle. So if naa siya sa critical path, dili siya pwede ma-delayed. So mo na siya ang atong pangitaon. So where are the path nga dili siya pwede ma-delayed o where are the path nga pwede siya ma-delayed pero kanang ang iyahang finish time won't be added or kanang same gihapon iyahang finish time. So next. So here we'll proceed on determining the critical path. So we begin by finding the earliest start time and the latest start time for all activities in the network. So let ES be the earliest start time for an activity and EF is the earliest finish time for an activity. So T here is the activity time. So the earliest finish time for an activity is earliest finish time is equal to earliest start time plus the time. So here, so we assume, no, not assume. So here, the earliest start time of A, for example, in A. For example, in A, its earliest start time is 0. Why man? Because A kay kanang can start immediately man wala man siya giagad na lain activity as well as sa B, di ba? Zeros ang iyang earliest start time so kanang pinakasayo nga pwede mag-start ang usa ka activity is 0. So mo na siya, so mo na ilang earliest start time. Then ang earliest finish time nila is 5. Why? Because 'di ba ang formula is earliest start time plus ear earliest start time plus activity time. So its activity time is 5 man and dinhi kay 6, 'di ba? So therefore ilahang earliest finish time is 5, also 5 and also 6. So mo na siya ang unsang pag-get sa earliest start time and the earliest finish time. So next is the earliest start time for an activity is equal to the largest of the earliest finish times for all its immediate predecessors. So, 'di ba we already know that mm, 'di ba we already know that A its um earliest finish time so pinakasayo na mahuman ang activity A is 5 weeks and in B is 6 weeks. So therefore um in 'di ba ang A is ang mo proceed niya is C. So ang next sa A is C. So if pananglitan mahuman na ang activity A which is ang earliest kuan man niya ang earliest finish time is 5 weeks man. So mo na siya ang earliest start time sa C. Since inikahuman sa A, C naman dayon. So ang earliest finish time sa A mao ang earliest start time sa C. Mo na siyang pinakasayo nga ma-start ang activity C. So mo na siyang 5 ang earliest start time. So since ang earliest start time is 5 man, so plasan nimo siya 4 which is the activity time. So therefore ang earliest finish time niya is 9. So that is um the formula. So next is B. Let's have here in B ha para kuan. So sa B, earliest start time niya is 0 and its activity time is 6. So ang iyahang earliest finish time is 6. So since um here observe, 'di ba sa C, iya pong ang mosunod sa C is H. Then sa B, ang mosunod po niya is H. So asa man ang unsa man ang sundon sa H? Unsa man iyang sundon nga earliest start time? Ang earliest finish time ba sa C or ang earliest finish time sa B? So kana siya, ang imuhang dapat sundon is the biggest earliest finish time. So since ang bigger earliest finish time rather is ang C man, since 9 man ang C, then 6 raman ang B. So 9 ang iyahang earliest kanang earliest start time sa H. So 9 iyang earliest start time. So 9 plus 12 is, wait lang, 9, we have here 9 plus 12 is equal to 21. So therefore ang earliest finish time sa H is 21 and iyang earliest start time is 9. So let's proceed. So kani siya na figure 9.5 is the kana siya kanang na-compute na siya tanan. So let's check. So 'di ba sa H is, 'di ba sa H you can see that 9 ang gisunod na earliest start time, kanang compare sa 6 ba. So mo na siya. So next is kanang kung giunsa nato pag-solve ang C, H, and B, kinato pud pag-solve ang um the rest of the nodes. So what siya? So ang earliest finish time nato is 26. So the project can be completed in 26 weeks. If wala siya, if matuman iyang earliest start time ug ang iyang earliest finish time. So next, the latest start time for an activity can be computed as follows. So latest start time for let LS be latest start time for an activity and LF be latest finish time for an activity. Then latest start time is equal to latest finish time minus T. So the latest finish time for an activity is the smallest of the latest start times for all activities that immediately follow the activity. So here we will do the reverse computation. So 'di ba sa kaan 'di ba nag-start is ari sa start. In getting the latest start time and finish time, ari ta mag-start sa finish. Ari ta mag-start sa finish. So for example, 'di ba ang formula is latest start time minus um latest start time minus ito ba? Latest start time is equal to latest finish time minus activity time. So therefore i-minus nato ang, 'di ba mo ni siya ang latest mo ni siya ang earliest finish time. 'Di ba mo ni siya ang earliest finish time. Therefore ang kaning earliest finish time mo ni siya ang latest finish time sa sa activity I. So, if i-minus na 'to ang finish time minus 2, we will get 24. We will get 24 here. So, ang 24 na 'to mo ni siya ang latest earliest ah mo ni siya ang latest start time. So, mo ni siya ang kanang pinaka-late nato nga pwede makasugod sa kanang activity I. So next is the koan. For example, kaning G. So, since 24 man ang latest, um, 24 ang latest start time dinhi, so ang latest finish time dinhi sa G is 24 as well as sa H, 'di ba? So, 24 minus 14 is equal to 10. So 10 is the latest start time sa G and 12 ang latest start time sa H. So kanang kung giun sa pag-solve ang I, H, and G, mao pod unsaon pag-solve sa the rest sa mga nodes. So mo siya makabalo na ka kung unsa ang earliest pwede ni ang earliest start time or kanang kung kanus pinakasayo magsugod unya makabapog ka sa kanus pinaka-late magsugod ang usa ka activity and makabapog ka kung kanus ang pinakasayo nga mahuman ang usa ka activity o pinaka-late mahuman ang usa ka activity. So mo na siya ang sa PERT CPM nga principle. So next is kanang we proceed to slack. So slack is the length of time an activity can be delayed without increasing the project completion time. The amount of slack for an activity is computed as follows. So slack is equal to latest start time minus earliest start time or latest finish time minus earliest finish time. So the slack for each activity indicates the length of the time the activity can be delayed without increasing the project completion time. So 'di ba ang project completion time na to is 26 weeks. So um ang slack ko no indicates the length kung kanang unsa ka taas ang time nga pwede nimong ma-consume para, maski ma-delayed ang usa ka activity is 26 weeks gyapon excuse me, 26 weeks gyapon ang imong project completion time. So in general, the critical activities are the activities with zero slack. So when we mean zero slack, so dili siya pwede ma-delayed since wala man siya slack. Ang slack is length baya sa pwedeng length sa time nga ma-delayed ang usa ka activity. So kung wala siya slack, so zero iyahang length sa time. So dili siya pwede ma-delayed. So for example, the slack associated with activity C so is LS minus ES. So 8 minus 5 is 3 weeks. So hence activity C can be delayed up to 3 weeks and the entire project can still be completed in 26 weeks. So whether um if ma-delayed man galing og 2 weeks or 1 week or 3 weeks ang activity C sa pag-start o pag-finish, still ang entire project niya is mahuman gapon to 26 weeks. Next, we consider activity E. So we find that the slack is LS minus ES is equal to 5 minus 5 is equal to 0. Thus, activity E has 0 or no slack. Therefore, activity E is a critical activity since dili siya pwede ma-delayed. So, so here in table 9.2, you can see kanang which activity has a critical path. So, 'di ba earliest, 'di ba zero ang slack sa activity A. So, dapat dili siya ma-delayed. Kani pong activity E, activity F, activity G, and activity I. So these are the activity which is a critical activity. Therefore, kani sila nga mga activity can never be delayed. But here in activity B, in activity B, pwede siya ma-delayed og 6 weeks. And C, pwede siya ma-delayed in 3 weeks. And D, pwede siya ma-delayed in 2 weeks. And H, pwede siya ma-delayed in 3 weeks. So, even though ma-delayed siya, still ang ilang project completion time is still 26 weeks. So, we already know how to compute the PRT or CPM. So, now let us know the contributions of P PERT and CPM. So first, 'di ba kanang PERT and CPM as what I have introduced in last slides in kanang sa ako introduction is that it can answer those questions. So these are the questions. So how long will the project take to complete? So the answer, since kanang we already compute, 'di ba, the earliest start time and the earliest finish time, latest start time and latest finish time, we'll be able to know, or we will be able to answer those questions. So, for example, mo to siya, question number one. So, the answer is the project can be completed in 26 weeks if each activity is completed on schedule. So, number two, what are the scheduled start and completion times for each activity? So, the answer is the activity schedule shows the earliest start, earliest finish, and latest finish times for each activity. So number three, which activities are critical and must be completed exactly as scheduled to keep the project on schedule? So answer is A, E, F, G, and I are the critical activities. So here the A, E, F, G, and I are also the critical path, di ba? As I've said earlier, ma-prove na to nganong ang um longest path is the critical path. Here na natubag na since we already solved it. So ang AFGI is the longest path, and also when we solve it, it is also the critical path. So therefore we can conclude that the longest path is our critical path. So number four, how long can non-critical activities be delayed before they cause an increase in the completion time for a project? So the activity schedule shows the slack associated with each activity. So it differs in each activity, di ba? Sa last. So here in table 9.2, di ba? Makita nimo pila ka weeks ang pwede niya ma-delayed in each activity. So next. So here for better visualizations, just um try to see it on kanang sa katong resource nga naa nato. So or in the book. So kani siya dinhi na nato makita ang sa Microsoft Office project activity schedule for the Western Hill Shopping Center project. So in activity A, 5 weeks man ang duration. So gibutang na diri kana sa mag-start, kana sa late mag-start, kana sa ang early finish and late finish. So iya na siyang gibutan og date. So mo na siya gibutang kung pila ang total slack, and if this activity is critical. So next is the summary of PERT or CPM critical path procedure. So develop a list of the activities that make up the project. So muna ang first step, 'di ba? Develop list. Dapat kabalo ka kung unsa nga mga activities ang naaanang nga imuhang project. So step to determine the immediate predecessors for each activity in the project. So dapat you will know unsa ang mauna, unsa ang sunod, and unsa ang maulahi. So step 3, estimate the completion time for each activity. So kanang you must know or estimate baron what are the certain times kung kano sa mahuman ang certain activity. So step 4, draw a project network depicting the activities and immediate predecessors listed in steps 1 and 2. So 'di ba? Um 'Di ba, as what I've said a while ago, that immediate predecessor is helpful in having project system. So mana siya, I mean project network system. So step 5, use the project network and the activity time estimates to determine earliest start and the earliest finish for each activity by making a forward pass through the network. The earliest finish time for the last activity in the project identifies the total time required to complete the project. So, step 6, use the project completion time identified in step 5 as the latest finish time for the last activity and make a backward pass through the network to identify the latest start and the latest finish for each activity. So, kaning step 5 is katong pagpangitan nato sa earliest start time and earliest finish time, and here in step 6 is the latest, di ba, katong reverse computation wherein kanang we find the latest start time and the latest finish time. So in step 7, use the difference between the latest start time and the earliest start time for each activity to determine the slack for each activity. So in step 7, we determine the slack or the length of the time that an activity can be delayed. So in step 8, find the activities with zero slack. So these are the critical activities. So what is siya, through finding the slack or through computing the slack, we will identify what are the activities that is critical or can't be delayed. So in step 9, use the information from steps 5 and 6 to develop the activity schedule for the project. So, di ba, last time is last ang katong ato ang gisolve is naay certain time. So how about if uncertain yung activity time? So here is the problem. So the HS Doherty company has manufactured industrial vacuum cleaning system for many years. Recently, a member of the company's new product research team submitted a report suggesting that the company consider manufacturing a cordless vacuum cleaner. The new product, referred to as PortaVac, could contribute to Doherty's expansion into the household market. Management hopes that it can be manufactured at a reasonable cost and that its portability and no cord convenience will make it extremely attractive. Doherty's management wants to study the feasibility of manufacturing the Portavac product. The feasibility study will recommend the action to be taken. To complete this study, information must be obtained from the firm's research and development, project testing, manufacturing, cost estimating, and market research groups. So how long will this feasibility study take? So here, these are the activities for making a feasibility study of Portavac project. So we have activity A from to J. So these are the descriptions. So A, develop project design. B, plan market research. C, prepare routine or manufacturer engineering. D, build prototype model. E, prepare marketing brochure. F, prepare cost estimates or industrial engineering. G, do preliminary product testing rather. H, complete market survey. I, prepare pricing and forecast report. And J is prepare final report. So in immediate predecessor, it is to be said that A and B is still A and B is still kanang immediate can be start immediately rather. So and C, D and E, you cannot start activity C, D and E without finishing activity A. So and in activity F, you cannot start activity F without finishing activity C. And activity G, you cannot start without finishing activity D. In H, you cannot start if you haven't finished activity B and E. And I, you cannot start without um finishing activity H. And in J, you cannot start activity J without finishing activity F, G, and I. So here are the project network system of Portavac cordless vacuum cleaner. So start A, B, then in A you cannot start C, D, E can start without A. So um muna siyang after CSA. So an F, G, H as well as J and I. So muna siya. So to incorporate uncertain activity times into the analysis, we need to obtain three time estimates for each activity. So first is the optimistic time. Second is the most probable time. Third is the pessimistic time. So A is equal to the minimum activity time if everything progress ideally. So M is the most probable activity time under normal conditions. And B is the maximum activity time if significant delays are encountered. So using activity A as an example, we see that the most probable time is 5 weeks with a range from 4 weeks, which is 4 weeks mo atong optimistic time. Ang 12 weeks is the pessimistic time. And here, ang 5 weeks mo na siya ang most probable time na to. So, if the activity could be repeated a large number of times, what is the average time for the activity? So this average or expected time is computed as follows. So T is equal to A plus 4M plus B over 6. So for activity A, we have an average or expected time of, so 4 plus 4 times 5, di ba? 4 times 5 is equal to 20 plus 4, 24. So plus 12 is equal to 36. So 36 divided by 6, we will have 6 weeks. So the average time for here for activity A is 6 weeks. So the variance of the activity time is given by formula. Standard deviation is equal to B minus A over 6 squared. So the difference between pessimistic B and optimistic A time estimates greatly affects the value of the variance. So large differences in these two values reflect a high degree of uncertainty in the activity time. Using equation, we obtain the measure of uncertainty that is the variance of activity A denoted A standard deviation squared A. So standard deviation squared A is equal to 12 minus 4 over 6 squared. So 12 minus 4 is equal to 8. So 8 over 6 squared. So we will have 1.78. So here the 1.78 is the um uncertain time sa kanang between the pessimistic and the optimistic time. So as here observe table 9.4, so optimistic most probable and the pessimistic activity time. So time estimates for Porta Vac project in their feasibility study. So in activity A, we have optimistic for most probable 5 and pessimistic 12. So in B we have 1, 1.5 and 5, C 2, 3 and 4, D 3, 4 and 11, E 2, 3 and 4, F 1.5, 2 and 2.5, G 1.5, 3, 4.5, H 2.5, 3.5 and 7.5, and I 1.5, 2 and 2.5, and in J we have 1, 2 and 3. So these activity or the optimistic, most probable and pessimistic time is not solved ha basin na tingala mo asa man ni ang 4 uy nganong naabot man siya og 4 naabot siya og 5 nganong night 1 night ang C kay ang iyang optimistic is 2 ana. So if you're wondering asa na siya gikan, so those are just an assumption sa kana nga business sa kaning Portavac nga project. So as gi-assume nila nga ang activity D is ang iyang optimistic time is 3, iyang most probable is 4, then ang iyang pessimistic is 11. So mga assumptions ra na siya. So also equations are based on the assumption that the activity time distribution can be described by a beta probability distribution. So the continuation of the report um will be tackled by my partner, which is Rufa May Godinez. So that will be all for my report. Thank you so much for listening.